So I hope you liked that video about the definition of a limit. That definition is going to take us through most of this unit, and if you could read all the I call it gobbledygook of other ways to define limits, but that concept is what's going to take us through. So I just want to emphasize a few other key points in regards to limits and just make some notes here. When we talk about the definition of limits, I'm going to assume that you wrote down the notes from the last example where I said it's the height the graph intends to reach. But in just some notes here, most limits in the real world can be viewed as numerical limits. So most limits in the real world can be viewed as numerical limits. Of values of functions. Okay. A calculator can suggest limits. A calculator can suggest limits to you graphically and numerically. And basically, calculus will confirm it for us. So calculus can confirm algebraically. Confirm algebraically your limits. Calculus can confirm limits algebraically. Okay, the previous example that we looked at was an example of a limit. Okay, an example was from our previous example. We looked at a problem where we wanted to know the average speed was not defined when h was 0. But we selected, but we put it, basically what we did was speed was not defined. At h to equal 0. But basically, we approached 96 as h approached 0. So as we let h be 0, we got closer and closer to that value of 96. So the graph intended to reach that height of 96. Now, we can't always, sometimes this strategy will work where we can see the limits algebraically, numerically and algebraically. By eliminating the h in the denominator. So we did that in one of the examples earlier. That's a great strategy. It doesn't always work. For example, we could do a problem like this. It does not always work. And we're going to need to learn some other strategies. It does not always work. Sometimes we might have a question like this: f of x equals the sine of x over x, and we're not going to be able to eliminate the h. Okay, but we are going to be able to figure out later on that the limit as x approaches 0 of sine of x over x, if you graph it, you're going to see that that intended height intends to be 1. We just need another way to prove it. So we're going to need some other methods in this course. Okay. All right, so let's dive into some examples now of some of the properties of limits and just how they're going to work, or just some of the ways to work with them. So we're going to look at a problem where we're going to look at the limit as h approaches 0 of 64 plus 16h. Okay, this one we don't need to do anything with the denominator. We can just substitute right in. So when I substitute right in, that's just going to give me, it's going to be equal to, when I substitute in, I don't need to write limit anymore for notation. I'm going to get 64 plus 16 times 0. So I just get 64 would be the answer to that. All right, now we might look at a problem like this where we have f of x equals x squared minus 1 over x minus 1. And I'm asked, what is the limit as x approaches 1 of f of x? Okay, Well, that is the limit as x approaches 1 of x plus 1 times x minus 1 over x minus 1. X minus 1's cancel, and I'm left with the limit as x approaches 1 of x plus 1. So 1 plus 1 results in 2. Okay, that's just some simple substitution, pretty straightforward types of problems.